Okay, kids, now I have one more problem to demonstrate the nodal analysis here. So first, can we apply the branch current or say loop analysis? How many loops are there? Like it 1, 2, 3, 4, 5, 6. Let me count 1, 2, 3, 4, 5, 6, 7. 7 loop currents. 1, I1, I2, I3, I4, I5, I6, I7. Then 7 unknown things. Solving 7 linear equation. Very difficult, very lengthy. See, as the number of loops increases, then using the loop analysis will be very difficult, a loop current method. Okay, shall we go for branch current method? Again, the same difficulty. Let me send a current I, then I by 2, I by 2. Again, branching current is also very difficult. Are there series parallel? Nothing. Vistro network? Nothing. So what we have option is the nodal analysis. As it will simplify when a very less time, we can easily find out the current in all the branches. So what is asking though? Find the current through the branch X5. This was the question that is asked here. What I do is like, I will find out the across this resistor, the current has to be determined. So let me define the potential. So this will be 50. So the potential difference across cell is 50. So here the potential difference will become 50 plus X. 50 plus X. Let me define the potentials. 50 plus X. Then this potential of this should also be 50. Any reason for that? Why we are doing? So that everything is of same potential, no? It's a one wire, common wire. So the potential of everything, this should be 50 plus 6. Okay, now justify know what is the EMF of cell? 50 volts. So 50 plus X minus X will be 50 volt. Then, okay, let's come for this cell. The EMF of this cell is 100 volts. Okay, that's some correction is there. Just I made some changes to the network. No. Okay, what should be the potential of this? EMF of this cell is 100 volts. So potential difference across these 2 points should be 100 volt. So here I will define the potential at this point. Let it be 100 volt. Then potential of this should be 0 volt. Okay, this also you can define node B. There's a node A, node X, node Y. So altogether we have defined now 4 nodes X, Y, A, and B. And there'll be some flow of current through this, because the current should at this of higher potential. So therefore current should leave this positive terminal. Let me assume this current high. Okay, like this, I define the potentials at various points. Let X be the potential here at the node X. Let Y be the potential. So what are the nodes we have? X, Y, A, B. We have defined the nodes. Okay, let's start with the at node Y. I will write it node Y. Okay, there's all this content is for previous one. Okay, you not get distracted. This is later on. I'll bring it. Because only I want you to only see this network. Okay, now come for this one at node Y. How to write the node Y? Algebraic sum of currents entering should be equal to algebraic KCL. Algebraic sum of currents at node Y should be 0. So Y minus 100 by R y minus 50 by plus x r, and there are such two nodes, are the two branches are there, no? Here it will be y minus x by r, all set equals 0. What is this? How I wrote all this one? Y minus 100 by r, y minus of 50 plus x, coded by r. Like this, these two branches are similar. You can see potentials at these nodes 50 plus x, 50 plus x. So twice y minus x by r, y minus 0 potential. Y is a potential here, not symbol it is. Vy, instead of writing Vy, I'm writing y. X and y are potentials at nodes x and y. Y minus 0 by r. So solving this. Okay, we'll get the thing that one. So there's a one equation. Yeah? Now let me directly take current entering. So this, what is the current? How much of current enters negative term? That much of current should leave. So current leaving at A should be equal to current leaving at B. Let me take help of this data. So what is the expression for this current? So 0 minus y, 0 minus y. So let me write that one. So 0 minus of y by r, 0 minus of 50 plus r. That should be equal to current leaving at A equal to current entering at B. You can see here current, it leaves the node A, no, and at B this current enters, and that should be equal to 100 Okay, solving, how many unknowns are there? So what is R? R in fact equal to ohm. Solving this equation 192, we'll get x and y. So x will be minus 25 by 2 volt. Y will be 125 by 2 volt. I can easily find out the current. Find the current through this branch. Okay, let this be I naught. So what is Vy? Vy minus I naught R minus Vx equals 0. So Vx, sorry, Vy. Vy is y minus x by 2 ohm. Substitute value. Y is how much? 125 by 2 minus of 25 by 2 by 2. 125 plus 25, 150, 150 by 4. Let me check the value. 150 by 4. 37.5 ampere. Okay, this is the current flowing through the branch XY. Okay, nodal analysis. See, it is really simplified our calculation. Without this nodal analysis, we have other methods, but they'll be very, very lengthy. Just writing 2 linear equations and solving, will it be convenient? Or writing 7 linear equations and solving the 7 linear equations? If you go for nodal analysis, X and Y are 2 unknowns in the entire whole circuit. If you go for loop current method, 7 unknowns will come. Solving 7 linear equations will be very lengthy, time consuming. Therefore, the nodal analysis is preferred when you have more than 1 loop, because it will minimize the mathematics.